Our topic today is the limits concept. When limits x tends to a number a or number when x tends to 0, third limit when x tends to plus infinity, and fourth the limit x tends to minus infinity. We will define it one by one with the examples. When it x tends to a, suppose they have a question like this, that limit x tends to a means any numerical number 2 of x plus 2, then you will put this x is equal to 2 in it, so it should be equal to 2 plus 2, and that thing is equal to 4. If you put the limit x tends to 2 and it is 1 over x minus 2, then when you put x is equal to 2 in it, it will become 1 over 2 minus 2, that thing is equal to 1 upon 0, and 1 upon 0 is equal to infinity. We know one thing from this part, that 1 upon 0 is equal to infinity, 0 upon 1 is equal to 0. And for this example, let's say they are defining limit x tends to 2, x square minus 4 over x minus 2. Directly this will come infinity, but if we approach it with the factorization, that first we have to factorize both numerator and denominator, then this limit x tends to 2 will become x plus 2 into x minus 2 over x minus 2. This and this, they are going to cancel out. It should be equal to the limit x tends to 2, x plus 2 there. And finally, it should be equal to 2 plus 2, and that thing is equal to 4. Suppose limit x tends to 2, x square minus 4, then you can put it like this, 2 square minus 4, and that thing is equal to 4 minus 4, or that thing is equal to 0. So these are the limits when it is approaches towards the point A there. Then we can have this example there, let limit x tends to 0, and we are going to define out for x square minus 9 over x plus 3. Then what you are supposed to do, you will first simplify it with a simple factorization. Limit x tends to 0, it should be equal to x plus 3, x minus 3 divided by x plus 3. This and this, they are going to cancel out. And now you put the limit in it. So it should be equal to 0 minus 3, and that answer is equal to minus 3. So whenever it is approaches towards 0 or any finite number there, then you will directly put r. First, you are going to factorize it, and then you can put, and then you can get the values of this limit point for this approaches towards the 2 points when x tends to a or when x tends to 0. Now, this is again the factorization of this, because if you directly put x is equal to 4, then it will become undefined. So let's first factorize it and then put the limits. So limit x tends to 4, we take the LCM here, it should be equal to 2 root x, and it should be equal to x and x cancel out, so it should be 2 minus 2 and 2 cancel, so it should be equal to 2 minus root x divided by x minus 4. Then the limit x tends to 4, it should be equal to 2 minus root x over 2 root x into x minus 4. Now you make the conjugate of this, so it should be multiplied by 2 plus root x and divided by the same conjugate 2 plus root x there. So it should be equal to limit x tends to 4. It is a minus b and a plus b, so it should be equal to a square minus b square. So that should be equal to 4 minus x over 2 root x into x minus 4 there. But this will become limit x tends to 4. It is 4 minus x and it is x minus 4. So minus 1 is taken common there. So it will become x minus 4 over 2 root x into x minus 4. X minus 4 and x minus 4 is cancelled out. So it should be left equal to limit x tends to 4 minus 1 over 2 root x to that. And when you put the limit x equal to 4, it should be equal to minus 1 over 2 into 4 square root. That is minus 1 over 2 into 2, and that is equal to minus 1 over 4 is the answer of this question there. So this is the way that you are going to solve when limits are x tends to a or x tends to 0 for these fractions there. And then we are going to solve this next part when x tends to infinity or minus infinity for all this in the form of these fractions there are simplest fraction. Sorry, we have not used this part. It should be, this factor is also there. It should be 2 plus square root of x. So it should be 2 plus square root of x. So finally it should be equal to limit x tends to 4 minus 1 over 2 square root of x into 2 plus square root of x. Now we put the limit on it. It should be equal to minus 1 over 2 into 4 square root into 2 plus 4 square root. So that should be equal to minus 1 over 2 into 2 into 2 plus 2. So that should be equal to minus 1 over 2 2s are 4 and this is 4. So 16. So this is the answer of this for the limits when x tends to 4 there. So whenever it tends to some values, then first you will put it, if you directly get the answer, well and good, but if not, then you have to factorize it or make some process for that algebra there, either multiplying or dividing or something ever which is required for this question, and then put the limits, then you will get the answer of this whole question there.